Hi everyone, I am Demalopal. Today in this session, we are going to discuss on a very important topic of databases called indexing. The prerequisite for this session is to have a basic understanding on algorithmic analysis. Before we jump into what indexing is, let us see a real life scenario. Let's suppose we are in a geography class and our teacher asks us to open our book and find out where coral reef is. So how can I do it? I don't know in which subject, in which chapter the coral reef is. But in the books, majorly we have a section at the end called indexes. What does it have? It have all the list of important topics and the associated page numbers. So I can just go to the end of the book, search for coral reef in the indexes and just jump over to the page number given there. Right? Okay. Now we will see an example of database and understand how indexes are related to database. Okay, so here is an example. We have an employee table which has three fields: ID, name and age, and this table has 5 records. Let's say I am performing a query. I am firing a query on this table in which I want to find out all the employees who have an age of 19. How the execution will go on? So the execution will go on for each of the element. It will traverse all the records and for each it will perform a condition check whether the age is equal to 19 or not. So after the execution we will get the result. So how is the query operating? For the operation, each of the element is being checked. So can we visualize it as a linear search kind of thing? If not exactly linear search, still it is traversing all the records. That is giving us a time complexity of order of n. Okay, here we have 5 records. It does not matter that much. But when we have tables of millions of records, or we are performing some complex query where we are joining multiple million tables, that is pretty complex. That would take huge time in this case when we are having order of n kind of algorithmic complexity. But here comes the concept of indexes to our advantage. So what is indexing? Indexing is basically tracking the elements or tracking the records in an organized manner. How can we do indexing? Let's understand. So usually we perform indexing on columns or fields in a table, and what do we get? We get the elements of that field in sorted manner in another table, and for each element we store the associated reference to the associated record in the memory. So let's understand more clearly. For employee, we were performing the query on age. We will also apply index on age field only. On applying index, on creating an index of age, we get all the values of age in a sorted manner, and for each element of age, we have a reference to the associated record. Let's say this 19 is for this record. ID is equal to 3. So this or this. Same. Let's say for 28, we have mapping for the reference of related record. ID is equal to 1. This. So age is 28 and this is the record. Okay. So do we observe we have a sorted ages? The age is in sorted manner here. So since we have to find a particular age, we have to do a condition check and the data is sorted, we can visualize it as a binary search. We can imagine it like that, right? So what is the complexity in that case? It is order of log n. So previously it was order of n and now it is order of log n. It is a huge improvement. Okay. Now, when do we want to do indexing? Do we want to have indexes every time we create a table or every time we add a column? Absolutely not. We only want to have indexes when we have huge amount of data in our tables and the operations that we are performing in tables are read intensive. Fine. The next thing that we want to concentrate on is on which columns do we want to create indexes. Is it for all the columns? No. we want to create indexes on only those columns which are mostly used for conditional checking or sorting in our queries. For example, let's see. And the first query that we used was having a conditional check on age. The second thing can be when we want to find whether the age lies in a given range or not. In that case also, it is a conditional check. And at last, when we are sorting based on age, it is also indexes on age can also help us. Okay, so here we saw preliminary indexing, single level indexing. The next stage is multi-level indexing that can be obtained by using B trees and B plus trees, which is widely used in the production grade database software solutions like PostgreSQL, Oracle and MySQL. So yeah, that's it about indexing and how indexing helps us to optimize query performance. Thank you.